Hyperbolas. Hyperbolas. Which way does this open? You can tell by looking at the picture. Left and right. It's not left or right, correct? It's left and right. Where's the center? HK. Okay, so here's what I missed a second ago. Which way do we go for my vertices? We're going to go left and right, right? So how far left do I go? A plus, where's my center? H, right? I have to go however far A is plus however far H is. Does that make sense? So A plus H, and then how far do I go up? K. So where's the other vertex? It's the other way around. H minus A, K. I should have written that one H plus A, but sorry. So if this is a vertex and this is a vertex, where are the co-vertices? Where is a co-vertex? I mean physically in the picture. Where is it? Not corners. Because this was a vertex and this was a vertex. This is a co-vertex and this is a co-vertex. It seems useless, right? It doesn't do anything. But doesn't it? Doesn't it do something? What does it create? The box, the rectangle, right? Okay. Notice, please, how the rectangle is drawn. Dotted line, which means it's not really there. As well as the asymptotes are dotted lines, right? Which means they're not really there. We know that about asymptotes, right? So why do we even draw this box? Why is the box even there? What do you notice about the asymptotes and the box? They go right through the corners. And what do you notice about the shape of the hyperbolas? Follows the asymptotes. So the asymptotes will really help us create the hyperbola, and the box gives us the asymptotes. Okay? So we have to have these co-vertices to be able to draw the box so that we can draw the asymptotes so that we can draw the hyperbola. Okay? So co-vertices, H, comma, K plus B, and H, comma, K minus B. I promise this will make more sense when we're actually doing things with numbers. Okay? What about my asymptotes? Y equals, how many of them are there? 2, so we're going to have a plus or minus B over A times X minus H plus K. Once again, it will make more sense when we're actually doing stuff. Fair enough? All right, this one over here. How does it open? Where's the center? HK. Where are the vertices? Where are the vertices on this graph? Here and here, right? Because that's where the hyperbola lands on the box. That's a vertex. The other ones are the co-vertices. Fair enough? So H and then K plus B. Good. H and K minus B. Very good. Co-vertices. Good. Asymptotes. They're exactly the same. Okay? So let's do some actual examples. Fair enough? Okay. And then you'll understand that you actually understand all that stuff up there. Okay? Tell me where the center of this hyperbola is. 0, 0. What's A? Okay, I'll go with that. What about B? 3. Wait, how did you know A was 2 and B was 3? But I mean, how come this is not A? Always? A is always left and right. Where is A in the equation? Underneath the X. So is A always left and right? Yes. Okay? Alright, so where are the vertices here? 2, 0, and negative 2, 0. So if we actually like plugged everything into these formulas, would we get those two values? Yeah. What about covertices? Where are they? 0, 3, and 0, negative 3. What about the asymptotes? Do you want to use this formula? Neither do I. We can figure out the equations of lines, can't we? Y equals mx plus b. 1, 2, 3, 1, 2. Y equals 3 over 2x. And why don't they have a place for me to write b? Oh, it goes through the origin. So what's this other one? Negative 3 halves. So what's the equation? It's opening left and right, so which term is negative? The y. Okay? This is how I always like to write my hyperbola equations. This is how I start every time. I just give myself blanks to fill in. What goes in the top of the first fraction? X minus the x coordinate of the center squared. So just x squared because we're at 0, 0, right? Over what? A squared, which is 4. What about here? Done. Difficult or easy? It looks more difficult, doesn't it? Because there's a whole bunch more stuff with ellipses. Okay, what about B? This one must be harder. 3, 1, 2, 3, negative 2. So 3, negative 2 is the center. What's A? 1. What's B? 3. Where is the first vertex? 1, 2, 3, 1. How come you went here and not here? Why is it a covertex? The hyperbola doesn't live here, does it? It lives here. Does that make sense to you? Not the living part, you know what I'm saying. Okay? So a vertex is 3, 1. Where's the other vertex then? 3, negative 5. Where are the covertices? 2, negative 2, and 4, negative 2. Where are the asymptotes? Are they as easy this time? No, in fact, you can't even see where they cross, right? So we kind of need to use this formula, don't we? If we use the formula, we have y equals plus or minus b, which is 3, over a, which is 1, x minus the x coordinate of the vertex, which is 3, plus k, so minus 2. We could multiply that out if we wanted to, but isn't that an appropriate equation? Couldn't you put that into your calculator and get an answer? Yes? Okay. What about the equation? X minus 3 squared, y? Because the center is not at the origin. Okay? Over what? A squared, which is 1. Oh, what? I messed up? Oh, okay. It's up to you. It's up to you. If you want to think I did it on purpose or if I did it on accident, it's fine. But does it really matter? Oh, yes, it does, doesn't it? Okay. So y plus 2 squared over 9 equals? Good. Questions? I know it. We're going to graph a hyperbola now. You need to remain calm. Write down the center. Where is the center? How do you know that the center is at 3, -1? Because you just do, right? HK. All right? So let's find 3, -1. 1, 2, 3, -1. There's the center. Okay? What's A? 4, and we found 4 by... Okay, so along the x direction. Now, please notice I didn't say x-axis. We don't need to go on the x-axis, do we? We just need to go the x direction, left and right. We need to go 4 each way, right? So from the center, 1, 2, 3, 4. From the center, 1, 2, 3, 4. Where are those 2 points? Okay, so far? Write down B. 3. So the vertical direction, the y direction, we need to go 3. Where are those points? Okay. Use these vertices as midpoints of the sides to draw a box. What's the most common thing that people do wrong here? They connect dots. Don't do that. Okay? That is not what's happening here. These are midpoints of the sides. Like this. And how did I draw my box? Dotted lines, right? And I draw it dotted because it doesn't really exist. It does give us lots of good information, though, about our hyperbola, right? Now, opposite corners. Here are the asymptotes. Opposite corners. Should this asymptote always go through the center? Always? You know how I feel about using words like always. Should it, though? Yeah. There are rulers in the ruler home if you want one. So where's the hyperbola? This is where we have to come up with the hyperbola now. Where is it? Does it open left or right, or does it open up or down? Which term is positive? The x term, so if I closed my hyperbola, it would close on the x-axis. So that means it opens like this. What can it not cross? The asymptotes. What else can it not cross? The box, right? I can't tell you how many times in the past, obviously not you, because you guys are too smart, that people would do this, like an M. Or if like this was the asymptote, they go like this. Like a butt. We don't want butts, okay? We want hyperbolas. Don't go inside the box. Fair enough? So if I said you have to do these 2 for homework, are you okay with that? Could you draw hyperbolas? Good. Go to the next page. You also need to be able to write the equations. If you're given a hyperbola, can you do that? Look at number 4. The first part of number 4. Which way does this open? Up and down. So which term should be negative or which term should be positive? How do you want to think about that? Which term should be positive? The y should be positive, which means the x should be negative. So where's the center? -1, -2, so it's x plus 1, y plus 2. How far should I go on the x-axis? Or how far do I go on the x direction? Excuse me. I go 5. 1, 2, 3, 4, 5. So what number goes down here? And what about here? Done. Sure. If it helps you see where the numbers come, absolutely, you can just write 5 squared and 3 squared. Okay? What about this one? What goes where? 1, 2, 3. So the center is at -3, -1. So x plus 3 squared and y plus 1 squared. Right? Yes, sir? Absolutely. Absolutely it is plus y. But do you see why I give myself that template? Because that's easily fixable, isn't it? Okay, I just have to focus on that, make sure I remember that. How far do I go x direction? So this is, and what's this? Done. With hyperbolas, as with ellipses, we have foci. Okay? But here's the difference. Well, it's actually not a difference if I say that the foci are always inside the shape. Right? If we squeeze the shape, each focus would be inside the shape. If I squeeze this right here, wouldn't it squeeze the focus? See, the focus is going to be further away from the center at than the vertex this time. But it's still inside the shape. Do you see what I'm saying? Okay. The foci are always along the major axis. Does that mean, well, I don't want to say major axis. Let's use transverse axis, which is always the one that passes through the center and the vertices, not the co-vertices. Okay? So let's look at this first one in number 7. Okay? Oh, look at the formula this time. How is that different than yesterday? Okay, forget about the absolute value part. How is it different from yesterday's? It's not? So addition and subtraction are the same? Here was yesterday's, here's today's. Does that sign right there really make a difference? Huge, doesn't it? Okay. So, here's the equation that we're given for this hyperbola. How far is C away from the center? I already have a squared. If I add it to b squared, what do I get? 169. What's the square root of 169? 13. That means the focus is here and here. Oh my goodness, that's inside the hyperbola. So in this case, I have a focus at 13, 0, and I have a focus at -13, 0. Yes? Okay, let's look at C, please. Where is my focus? What is my C value? Because a squared plus b squared, 9 plus 16 is 25. What is the square root of 25? So my C is 5. So along this axis, the horizontal axis, because that's my transverse axis in this case, remember transverse axis goes to the center and the vertices. So in this case it's here. I need to go from the center 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's a focus. That's a focus. So this particular focus is at 7, 3. And this one is at -3, 3. The ones that we did not do are your homework. I hope you have a great day, and I hope you have an excellent weekend. Oh, one more thing. What am I going to say? You do have a flipped video for Monday. Okay? You do have a flipped video for Monday. Have a great day. Kingston out.